Okay, first of all, sorry if the lighting is a bit bad. I've got kind of a shadow on my paper here, but I've kind of pre-drawn out everything, so I'm just gonna kind of explain. So this is the graph that you originally had, and this is the graph of y equals log base 2 of x. And this is the table that I got by entering the equation into my graphing calculator. Let me show you. So it looks like this. So I just plotted those points onto here as best I could. So the horizontal asymptote is going to be y equals 0, and if you were to graph that, it would be this like diagonal line along like the center of the graph. And this is because this line is an exponential growth graph, and logarithm graphs and exponential growth graphs are like inverses. The x-intercept is going to be where our line intersects the x-axis, which is at 1, 0. And the end behavior, we learned as x approaches infinity, y also approaches infinity, as you can see, going this way. But as x approaches negative infinity, nothing. Y doesn't approach anything. That's because it's never going to cross, this line is never going to cross the x-axis, or the y-axis here. So yeah, moving on to the second question, we had to solve this logarithmic equation. And the first step is to check that you have the same bases on your logs, if there's a adding in between, or else you can't combine them. But they do have the same base, they both have the same base of 6. So that means that also, since there's plus sign, that the two, the x and the x plus 5 can be multiplied. So then you can have log base 6 x squared plus 5x equals 2. And so the next thing you're going to want to do is change to an exponential equation, which is going to be 6 squared equals x squared plus 5x, which is also, I thought I had it written down, oh yeah, 36 equals x. And so what we're going to want to do is set the equation equal to 0. So we do that by subtracting 36 on both sides. And once you get here, you can either do the quadratic formula or you can factor, which is honestly the easier route to take. Oh, and so you get x plus 9 and x minus 4, and if you set both of those equal to 0, you get x equals negative 9 and x equals 4. Now if you go back to try and check your work, you can see that plugging in negative 9 is like a non-real calculation, it's an error, and I think it's because you can't have a negative number in the parentheses here in your logarithmic equation. So we take that out, it's an extraneous solution, so then your answer is just going to be x equals 4. For the last problem, you're going to first of all define all your variables and figure out what they all mean. P naught is your starting value, P is your ending value, R is your rate, and T is your time. And time is what we're going to be figuring out here. They're asking us in how many years will the car be worth the ending value, 10,000. So the equation that we're going to be using is P equals P naught times 1 plus R to the T. And so we'll set it up just like that. And we want to start by getting this exponential on its own. And so we're going to divide by 40,000 on both sides. And you're going to get 1/4 equals 0.92 to the T. And so now you can change this to a logarithmic equation, and it's going to be log base 0.92 of 1/4 equals T. And if you plug that into your calculator, you're going to get 16.6259, and I rounded it to 16.63 years because we're talking about time. So yeah, that's it.